This video from Chapter 3 concerns equations of value, which is essentially an excuse for us to show you some perhaps slightly more challenging examples. And we'll use equations of value throughout the rest of the semester. So I'll step off the screen. Please pause, copy the notes down in your notebook, and then press play. All right, so an equation of value is a very simple idea. An equation of value is an equation in which the values of two different sets of cash flows are set equal to each other at a common time. So for example, we could say the value of cash flow A at time 3 years is equal to the value of cash flow B at time 3 years. And then we'd be looking to solve for some aspect of that cash flow scenario. Okay, so we'll do two examples. Example 1. Misha will receive $300 in 1 year and $500 in 2 years. Pavel will receive X dollars in 2 years and $3X in 3 years. At an annual effective interest rate of 5%, the present values of their cash flows are equivalent. All right, determine X. All right, well, so here's Misha, $300 at time 1, $500 at time 2. And we are going to drag them both back to time 0 because that's where we know the present values of the two cash flows are equal. Pavel, he gets X dollars at time 2 and $3X at time 3. Don't quite know if I read that correctly, but $3X at time 3. And we're also going to drag Pavel's money back to time 0 because that's where the two cash flows are equal. And for both sets of cash flows, we're going to use an annual effective interest rate of 5% as directed. Okay, so here's the present value. Here's Misha's present value, $300 times V to drag it back 1 year, $500, and the V squared drags it back 2 years. Pavel, the X dollars gets multiplied by V squared, and the 3X gets multiplied by V cubed to drag it back 2 and 3 years respectively. And remember, V is defined to be 1 over 1 plus I. Right? So it moves it back in time. Multiplying by V moves you back 1 period, in this case a year. So we have 1 over 1.05 for our V since I was 0.05. All right, so there I've copied everything out again, replacing the V's with 1 over 1.05s, 1 over 1.05 squared. The left-hand side cranked out to be 739.2290. The right-hand cranked out to be about 3.5 copies of X. And when I divided, I got an X value of $211.30. Now, when I'm doing these computations on my calculator, TI-30 for now, I'm using about 8 decimals of accuracy when I'm doing the computations. And then I'm rounding to the nearest penny. Now, I'm only showing you 4 decimals in each spot, but I'm actually holding the values up to 8 and just continuing to use the values in the calculator. Okay. Example 2 is a bit more challenging, and it introduces an idea that sounds really complicated, but it's not really. Okay, a deposit of X dollars is made into Fund A, which pays an annual effective interest rate of 3% for 12 years. At the same time, X over $4 is deposited into a separate Fund B, and that pays an annual effective rate of discount of D for 12 years. So 2 different interest rates going on here with different funds. The amount of interest earned over the 12 years in each fund is identical. Determine D, right? Well, that sounds complicated, right? There's a lot going on here for sure. But the amount of interest earned over 12 years is simply the accumulated value after 12 years minus the accumulated value after 0 years. It's how much our money has grown by. In other words, AV12 minus the present value. And the reason it's such a basic formula is because the only deposit into either Fund A or Fund B was right at time 0. So after that initial deposit was made for the next 12 years, the only reason the size of the fund is growing is because of interest or discount. So we can simply take the accumulated value at 12 years minus the amount that you started with to figure out how much interest you earned. Now, if we had thrown in some more deposits at time 2 and at time 4 and at time 8, this problem would have gotten considerably more complicated, right? But still, not too much more complicated. All right, well, let's look at Fund A. After 12 years, the accumulated value is the initial deposit, X dollars, times 1 plus 0.03 to the 12th, pushing it 12 years forward with annual effective interest rate of 3%. which gives me 1.4258 times x. Thus, the interest earned is the accumulated value after 12 years minus that initial present value, the initial principal, which was x. So I've earned 0.4258 times x worth of interest. We'll do the same thing for Fund B. The accumulated value at time 12 was our principal, PV0, times 1 minus d to the negative 12, since it's an annual discount scenario. And remember, our discount formula was the present value was equal to the accumulated value times 1 minus d to the t. So I'm just swinging the 1 minus d to the t power over to PV0, dividing it over, which is why I have a negative exponent there. All right, well, that doesn't simplify at all, unfortunately. But the interest earned then is that accumulated value after 12 years minus the principal, x over 4. And the only thing I really did is I dragged the x over 4 out in front, and there's everything else. We were told the two interest earns were equivalent. So I'm going to set the 0.4258x equal to the 1/4 x times 1 minus t to the negative 12 minus 1 right there. And good news, the x's cancel from both sides. So I did not need to know the value of x, right? Or this would have worked for any value of x. So the x's cancel from both sides. And now the only thing I don't have, the only thing I don't know is the value of d, which is what I'm trying to solve for. So now we're down to basic algebra, okay? So what did I do? I multiplied both sides by 4. I added 1 to both sides. I took the negative 1/12 root of both sides, and I got 1 minus d was equal to 0.9205. Solving for d, I got 0.0795 or 7.95% annual discount rate for Fund B. Okay.